Hi, I'm Maria Lopez. I'm a grad student from UC San Diego and welcome to my channel. Today we're going to talk about measures of association and how do we come up with these measures of association. Firstly, we're going to go over how to build up our 2x2 table so that we can do our formulas. And we're going to talk about different measures of association, including incidence proportions, risk differences, and risk odds ratios. For x equals 1 is those that were exposed to the factor of interest, and x equals 0 will be those individuals that were not exposed to the factor. For our outcome or our disease, y equals 1 means those that got the disease or those that we observed the outcome on them. And y equals 0 would be those people that did not get the disease or we did not observe the outcome on them. So this leaves us with a 2x2 table that is comprised of 4 cells. A being those people that were exposed to the factor that got the disease. B is those that were exposed but did not get the disease. The cell C would be those that were not exposed but did get the disease. And cell D would be those that were exposed and did not get the disease. When you look at the totals in the row, we would have A plus B, which is the total number of those exposed. And then we have C plus D. Those will be the total of people non-exposed. When we look at the column, then we have A plus C would be those that got the disease. And we say when we look at those that did not get the disease, then you have B plus D. Now let's look at our table again. We're going to put it really small on the top just for reference. And now we're going to talk about incidence proportion. So when we know that all of our sample got sampled or got measured at the same time for the same amount of time, which is 5 years, we can draw from this table our incidence proportion and our incidence ratios. When we look at incidence proportions, we can say that the incidence proportions for those that were exposed is equal to A divided by A plus B, or the total of the row of those exposed. The same way, when we look at incidence proportion for those that were not exposed, then we can see that if we take the cell C and divide it by the total of that row, which is the total of those non-exposed, then we get the incidence proportion for those non-exposed. The incidence odds, it's a function of probability, like we mentioned before. So the incidence odds would have a formula for those that are exposed. It would be the incidence proportion for the exposed divided by 1 minus the incidence proportion for the exposed. In the same way, you can gather the incidence odds for those that were not exposed, and the formula would look the same as the incidence proportion for those not exposed divided by 1 minus the incidence proportion for the non-exposed. This incidence odds simplifies the equation simplifies to A divided by B, and the same way for those that were not exposed, it simplifies to C divided by D. When we look at incidence proportion and its interpretation, we have to remember the incidence proportion is interchangeable with risk. So risk, in this case, the interpretation of the incidence proportion would be our risk, and we can read it as such. Individuals that are exposed have 1.5 risk of developing the outcome within 5 years of follow-up. When we talk about incidence odds, the incidence odd is used a little bit different, but for the meantime, we're going to talk about the incidence odds for a 5-year risk. It's equal to 1.5. Now, risk difference is, as the name says it, is the difference in risk between both groups, the exposed and the non-exposed. So our formula looks something like this. The risk difference would be the incidence proportion in the exposed group minus the incidence proportion in the non-exposed group. That leaves us with the interpretation as follows. The 5-year risk difference comparing study participants exposed to a factor to those who are unexposed was 4%. So our risk difference, we're going to interpret it a little bit different than the incidence proportion. Incidence proportion difference, or the risk difference, ranges from -1 to a 1, positive 1. We can see this example in a line where one of the end of the line to the left, it's -1, and then it crosses 0, and you have 1 on the other side. When we talk about risk difference, we have 0 is the null value, meaning that there is no difference between both risks in the exposed or the unexposed group. When we talk about 1, when we see a risk difference closer to 1 or far away from the null, we say that that risk or that factor causes a harm. It's a harmful factor. When the risk it's less than 0, meaning that it's negative, we can interpret this result as a factor that is protective. When we talk about risk ratio, we're talking about the ratio between the risk of those exposed divided by the risk of those on the non-exposed group. When we look at the interpretation of risk ratio, we read it as follows. The 5-year risk difference comparing exposed to unexposed is 2.33%. Now let's talk about odds ratios and the incidence odds ratios. If we remember, our incidence odds was a measure of probability, meaning that we looked at the incidence proportion divided by 1 minus the incidence proportion, and we got the incidence odds. So when we talk about incidence odds ratios, then we're looking at the ratio between both incidence odds, those that are exposed compared to those that are unexposed. So then our formula for the odds ratio would look like the incidence odds for the exposed group divided by the incidence odds of the non-exposed group. So that leaves us with A divided by B divided by C divided by D. So now let's look at the interpretation of the odds ratio. The odds ratio ranges from 0 to infinity, just like our risk ratio. So let's look first at an odds ratio that is greater than 1. So the interpretation would read, the odds of an outcome are, and you put the odds, times greater in the exposed compared to the non-exposed. Now, when an odds ratio is less than 1, then we're looking at a reduction of the odds. The odds of an outcome are 0.25 times reduced in the exposed compared to the non-exposed. All right, so that is all for today. Remember to subscribe to receive notifications for new content. I'm here to help you, and let's study together.